Hello, my name is Connor Grandin, and this is my Lab 7B traceback for this contest discussion. And it's definitely not Lab 8 because who the heck would modify their roundhead class when they're supposed to modify this? Okay, so this is what it looks like. You've got a bunch of rectangles of different colors, and then in the background you've got some shooting stars. So it's probably somewhere in space if you ask me. But if you run the code again, well, where the shooting stars go? Now it's just a bunch of these white stars. Well, if you read my my discussion post, you would probably know that it's totally random. Wow, I got all three of them in a row. You have the shooting stars, you got the twinkling stars, and you just have some clouds. So yeah, it might be a bit confusing why it looked different each time that I launched it, and that's because they are totally random. And here's why. When you open up the MU panel, I guess I'll focus on the background first. Basically, a random number is generated between 1 and 0 right here, and that is set to x. So then it goes to this if statement, which says that if x is greater than or equal to 0.6 repeating, that it will set the color to yellow and make the shooting stars. And then for the shooting stars, those are also placed randomly. There's 7 of them because this Q is set to 7, which means it goes through the loop 7 times. It generates 2 more random numbers, y and z. And then y will work as the x value, z will work as the y value, which is a bit confusing, and I probably could have named that a bit better, but here we are. And so, yep, lines are drawn, and then an oval is drawn in the middle. And then there's actually another for loop inside of this that helps to draw the tail behind shooting stars. And the way that this works is that an index starts at 0 and goes until it hits 10. So there's 10 lines being drawn. So there's this command for drawing a line. The first one is the x value plus 2. The second one's the y value plus 4. And that stays. That means that each line starts at exactly the same point. But then it actually goes until the x value plus 101, and then the y value actually varies on what the index is. So it's going to be the z value, or in this case, the y value. I'm sorry, I'm kind of confused about this too. And then you add 31. I'm not really sure why I picked 31. I guess that was just the best number. So you add 31 to z, and then you subtract that by the index times 5. And the index, like I said before, starts at 0. And each time it goes through the loop, it adds 1 on. So the first time it's going to be z plus 31, and then it's going to be minus 5. So it'll be, well, minus 0. So it'll just be at z plus 31. And then the second time it goes through the loop, the arrow, the line that makes up the tail of the shooting star will be z plus 31 minus 5, and then z plus 31 minus 10, and then z plus 31 minus 15. And that kind of sets up the effect. I can show it to you again. And to do that, we can... Let's guarantee it. We're going to manipulate the RNG 0.9. Semicolon. Okay, so since x is set to 0.9, I'm not really sure why they're going off the frame because I set them to be to stay in the frame, but you know what? It's whatever. They can leave if they really want to. So as you can see, well, it's kind of hard to see, but there's 10 lines coming off this star, and then each one has a distance of 5. So this is the first one that's drawn, but then 5 gets subtracted, so it moves on to this one, then 5, then 5, then 5, then 5, until all 10 are drawn, and then the loop ends. Okay, so let's fix that. But yeah, they're all placed in random places. It's supposed to be not go past 600 because the numbers in between 0 and 1, and when you multiply it by 600, the max it can be should be 600, and the edge of it is 800, so I don't really know why they would be going off the screen. So if anyone knows why that's going on, it would be pretty nice to know. But anyway, let's move on to the second thing, which are just the normal stars. So the normal stars actually use a very similar code to that of these ones. It's actually exactly the same as this, except this time they're set to white and they don't have the tails, and they also make 40 of them instead of just 7. And yeah, the same thing goes on for this, except I set it to be 790 max, which means they'll just barely be able to fit in the frame. And Z is set to 590 max, which also is barely in the frame, and that's the Y value form. And so those are pretty self-explanatory. The index is set to 40, so it goes through 40 times and goes through this code 40 times. It's generating random locations for each of the stars. And so yeah, the last thing is the clouds. And so I'll just keep going. So I start off with another for loop. The index is set to 10, so I'm going to draw 10 different clouds. Well, it starts at 0, it maxes out at 10, and it adds 1 at the end of each time it goes through the loop. I don't know if I forgot to mention that. Set the color to gray, and then again we set our constraints. The highest I want the x value to be is 600, or in this case, the y variable. Again, really sorry for that being so confusing. And for the z, the highest that can be is 590, because the clouds don't go that much up and down, but they do go a lot right and left. Okay, so I set a new integer, which is w, to 0, and then I tell it to go until it is greater than 15, but each time I actually make w increase by 2. And the reason for this is because I want to perform a mathematical calculation with the 15 that is going to be able to make the ovals line up. So basically I draw an oval, and the x value for it is the randomly generated x value that starts right here before the for loop. So it sees this y, and then it actually adds on this w, which is part of this for loop. And again, since the y is not in that for loop, it's not getting randomly generated over and over. It's the same thing for this for loop. So it takes that y value and it adds on the w, and the first time the w is going to be 0, so it would be y plus the w times 6. And so that would just be the y the first time. And then the y value for it is going to be z minus 6. And again, really sorry if this is confusing. And then down here it makes another oval, but this time it's the same thing, but the w gets an extra 1. And the reasoning for this is because I wanted to build a circle, let's say right here, and then I wanted the next one to be here, and then the next one to be here, which means the z value needed to be negative, and then positive, and then negative, and then positive, and then negative, and then positive. And so for that reason, I needed to fit 2 statements in here. One with the z being negative, and the other one with the z being positive. And so it subtracts 6 from the z, and then it adds 6, and then it subtracts 6, and it adds 6. And the fact that the y is getting the w added onto it times 6 means that it moves over 6 each time. So what ends up happening is that it starts at the y value, and then it moves over 6 and goes up to plus 6, moves over 6, it goes down to minus 6, moves over 6, and then the cycle continues. So yep, that's how the clouds are set up. And you know what? Let's run the odds. We're going to get the clouds. Don't even worry about it. Dang it. Alright, well, I actually found a solution to not getting the right thing, and you can actually move the window so that it randomly generates new things. So we're going to stop at clouds. Actually, kind of precise. Come on. There we go. Okay, so it starts at the Y value, moves 6, 6, 6, 6, 6, 6, 6, and then that makes it look nice. You know, like a real cloud would look like on a rainy day. At least I think so. Alright, so now we're going to move on to the rectangles themselves, which is a bit less complex. The first thing that I did was change the how many to 19. Before it was at 10, but I wanted it to fill up a bigger portion of the screen, so I made it 19. And the second thing that I did, if I can remember what it was, is when in here, wait, whoops, wrong thing. Wait, where am I? Those get drawn second. So I guess it would just be, oh yeah. So I changed the starting location of it, but that's not really the main thing. Oh, I drew it down here. Okay. My bad. So I changed the starting location of it. I changed the how many, and so what I did to make the colors change depending on what rectangle it is use a bunch of if statements and the remainder function. So basically, for each count in this, it runs through the for loop. So let's say, well, the first count is 0. And so what these do is it divides the count by 5. And then if the remainder is 0, then it says, okay, the color's green. So when it's 0, well, the remainder of 0 divided by 5 is 0. So the first one's going to be green. And then the second time the count is 1. Actually, I guess the count is 1 at first. So this one would actually be red. But yeah, the count continues until it goes through all of how many. So first one, it's green if it's divisible by 5. It's blue if it's divisible by 4 and not divisible by 5. It's yellow if it's divisible by 3 and not divisible by 4 or 5. It's magenta if it's divisible by 2 and not 3, 4, or 5. And it's red if none of these other things happen. So let's run it again so then you can see that. So yeah, as you can see, the first one's 1, so none of these things are happening. The second one is 2, and 2 is divisible by 2 and none of the other things, so it's magenta. Third one's 3, that's divisible by 3 and none of the other ones, so it's yellow. And then it continues on until the count hits 19. And I'm not sure if I thought I did something else, but yeah, I think that's pretty much it. Thanks for watching through my whole thing. I hope you enjoyed my demonstration, and have a nice day wherever you are.